Hi, hello friends. Welcome to T Academy. Let's continue the previous AE electrical question paper. So now I'm going to discuss the few questions from the AE previous papers, and the questions are from the subject of power electronics. Okay, so the first question here is when a voltage V naught sin omega naught t is applied to a pure inductor, an ammeter in the circuit reads I naught. If the voltage of V naught sin omega naught t plus 2 V naught sin 2 omega naught t plus 3 V naught sin 3 omega naught t plus 4 V naught sin omega naught t is applied to the same inductor, the ammeter reads in. So in the given question, there is a voltage source. Let me take this one as a V naught sin omega naught t is a voltage source is there, okay, which is applied to a circuit which is having a inductance, pure inductor here, that means no resistor, and there is a ammeter here like this. Now this ammeter reads the current of I naught. Okay, so I naught is equal to this a RMS value here. Okay, now when V naught sin omega naught is given, it's a I naught value. What about the magnitude of this I naught here? We need to find here. Okay, so let's assume that here omega naught L is a inductance here. Okay, now the first current, due to the first element here, what will be the current here? Okay, so due to this first order harmonics here, what you can get here, it is V naught, okay, so into sin omega naught t divided by omega naught into L. So this is a, okay, the first order harmonic current here. Now if you want to take about the magnitude here, let me take the magnitude I naught, which is equal to V naught divided by omega naught into L. So this is a maximum value. I want a RMS value. So I naught RMS is equal to Im by root 2. So I naught max by root 2. So from this V naught square root 2 omega naught L. So this is a I naught RMS value. In the given question, this is nothing but I naught value. So due to second order harmonic, that is this part. So I want to find the magnitude here, means due to second order harmonic here, what is the current? Current will be, what is the magnitude of V naught here? So here the magnitude is 2 V naught. So 2 V naught into sin omega naught into 2 into t divided by, so it's a second order, means here you have a 2 into omega naught into L here. 2 gets cancelled. If I found the magnitude here, so I naught RMS will be equal to I naught only here also. Similarly for third order harmonics also. So 3 V naught sin omega naught into 3t divided by 3 into omega naught L. So we'll get the same I naught value. So similarly for the fourth order also, same will get I naught value. Now overall RMS value. So overall RMS value is nothing but, so I naught total is equal to square root of I naught square plus I naught square plus I naught square plus I naught square. Okay, that implies 4 I naught square. That implies 2 into I naught. So answer will be D is the right answer for this question here. So let's move to the next question here. Okay, right. So this is the second question here in the examination paper, and here a single phase half wave diode rectifier with the input voltage 100 sin omega t is feeding into a resistive load of 100 ohms, the RMS value of the load current and the input power factor respectively. So there is a single phase half wave diode rectifier. So let me take a supply here. So voltage source is 10 sin omega t. Okay, there is a half wave rectifier, diode rectifier. Okay, and there is a resistive load here, and the resistive load is 100 ohms. 10 sin omega t supply. Okay, now what will be the RMS value of the load current and the power factor respectively? So first of all, we need to find the RMS value. So RMS value we need to find. So before going to discuss the RMS value, what is the maximum value? Imax is equal to, so 10 sin omega t, maximum value means 10 sin omega t divided by resistance value is how much? It is 100. It is nothing but 1 by 10 amperes. Now IRMS value we need to calculate here. So IRMS is for a half wave rectifier, it is Im by 2, that is 1 by 20 amperes, which can also be written as 50 milliamperes. So both are same. Now, so next one is an important one is input power factor. So input power factor is nothing but power delivered to the load divided by source VA. So power delivered to load by source VA. Okay, so it is nothing but here. So power delivered is nothing but IRMS value here. So IR square into R divided by VR into, sorry, it's not VR, it is a VS into IS. So IS and IR both are same here in the circuit. So IR square into R divided by VS into IR. So IR gets cancelled. So IR into R divided by VS is nothing but your power factor. Okay. So what is a IR here? You got it 50 milliamperes into resistance value is 100. What about the source voltage? Source voltage is Vs. So it is a maximum value. Okay. So what about the RMS value? Vm by root 2, that is 10 divided by root 2 here. So by solving this, you will get the answer as 0.707. So answer will be 50 milliamperes and 0.707 is the answer. So correct answer will be A here. Next question here. Right. A single phase full converter SCR bridge with a freewheeling diode is connected to a RLE load as shown in the figure. So where Vs is equal to 230 into root 2 sin 31t or 314t. Okay, the average load current 8 amperes is constant over the working range here. So here the current is 8 amperes is a constant value. When there is a current is constant, whatever the voltage across this inductor, VL is equal to L into di by dt. When di by dt is constant means it's 0. So voltage across this element will be 0 volts. Now what about the V0? So if we apply KVL here, minus V0 plus 0.5 into 8, okay, plus 120 is equal to 0. Okay, so V0 equal to 124 volts here. Okay, now considering this a full wave rectifier, so V0 is equal to 2 Vm by pi into cos alpha. Okay, so V0 value we know. What is the V0 value? Is nothing but 124 is equal to, so 2 into Vm value. How much Vm? 230 into root 2 divided by pi into cos alpha. So once you substitute and do the calculations, so alpha range will be 53.2 degrees. So answer will be D here. Okay, and let's move to the next question here. Right, next question. This circuit is from the choppers. The circuit shown in the figure, a second quadrant type B chopper, 2 quadrant type A or type C chopper, first quadrant type A chopper, 2 quadrant type B or type D chopper here. So first of all, draw this VI characteristics here like this, and the x-axis will consider the current I0 here, okay, and here minus I0, V0, minus V0. Observe the current flowing in the circuit here. So when the CH1 is start current flowing, the current will flow like this, the current will be positive. So this area it is going to be covered. Next one, when the CH2 is going to be working, the current has to flow from this inductance to this arrow mark direction here. So current will be here negative. That means it acts as a 2 quadrant type A or type C chopper here. So answer will be B here. Next one. So theory question here. Consider the following statement with regards to inverters. Okay. So line commutated inverters can be function as an isolated AC source. Force commutated inverters can be provide independent AC voltage with adjustable voltage and frequency. Thyristor based inverters do not require additional circuitry for commutation. IGBT P MOSFET based inverters are more reliable, less costly and less complex. So option 2 and 4 are the correct options. So for this question, the answer will be C here. So we'll move to the next question here. Okay. So this is the last question of this session here. So for the circuit shown in the figure, the dI by dt max and the dVA by dt max when the switch AC is closed at t is equal to 0. So here we need to find the dI by dt maximum value, dVA by dt maximum value here. So here it is nothing but a, we know this is called snubber circuit and is a this inductor here to control the flow of current here. Now the basic formula is V is equal to L into dI by dt. So we want to find the dI by dt. Okay, so V is equal to L into dI by dt. What is the L value? What is supply voltage here? So V is nothing but what? It is a 240 volts is equal to, okay, L is nothing but 12 microhenry and the dI by dt we need to calculate here. So from this dI by dt is nothing but, so it is 20 amperes per microseconds here. Okay, so 20 amperes per microseconds is the answer for this question here. Okay, now what about this dVA by dt? So for this point, what we will do is we will take the resistance value R is equal to dVA by dt divided by dI by dt. So from this dVA by dt is equal to R into dI by dt. What is the R value? 2 into, so dI by dt means 20 amperes. Okay, so R value here is a 10, sorry, it's a 10 value. Okay, 10 ohms, right? Here this value is 10. This is a lower resistance R. Okay, so that is a 200, okay, so volts per microseconds. So answer is here, it is B here. That's it for this session, friends. We'll continue in the next upcoming sessions. Thank you. Have a nice day.